Hello everyone. We are now going to move on towards the regression analysis. Until now, you have seen that we calculated the latent variable average score. Then we performed a correlation analysis. This is my model that for which we were analyzing the data. And you can see that I have three variables that are regressed against the EVOM credibility. So I'm going to perform a regression analysis related to the first part of my model, where I have three independent variables: quality of EVOM, then reputation of the website, that is RW, then we have attitude towards the EVOM. So these are the independent variables. We also call them predictors, and this is what we have as independent variables, which is also called as predicted variable or regressed variable. So moving on to the SPSS, how we do it. This is my data that I have here, and we will move on to analyze. We will go into the regression. Within regression, we'll go for linear regression. All right, click on the linear regression. Now you can see we have only one dependent variable that is available here. So I'm going down to my EVOM credibility. This is my dependent variable, and I will use the independent variables, review quality, then website reputation, and attitude towards the website. All of these are my independent variables. Now, what do I need to be calculated? That is available in the statistics. What do I need here? I need the estimates. I want the confidence interval. I want the Durbin-Watson. No, I'm not that much interested in that. That's okay. And yes, my confidence interval should be 95%. So that's what I want here. In terms of the plots, what do I need? I don't want any other plots from here. That's okay. So I'll click cancel. I guess that's very much that I want. I'll just click OK over here and I'll get the results. So this is my model results, the regression results. Okay, they would seem pretty nice, pretty good. Now, the first thing that we get over here as a result is our model summary. And the model summary over here tells us that my R square is 0.3 and overall R is 0.56. So what does this R square tells us? The R square tells us that how much percentage of the variation in the dependent variable can be explained by the independent variables, which is 0.32 over here. Now that means 32% of the variations in the credibility is determined by the changes in attitude towards EVOM, website reputation, and review quality. And the standard error of the estimate, it is 0.61651. Okay, this is one thing that you need to take care of, like you need to report this value, R square value. So we're not going to use the adjusted R square value because if only we are comparing models, that's when we compare the adjusted R square values. But if you're just reporting one model, you don't need to mention the R or report the R square, adjusted R square value. The next thing that we get within this table is our Anova table. Now this determines whether our model is statistically significant or not. Now there are three things that tell us whether the model is significant or not. One, it's the significant value. This sig value over here, if it is less than 0.05, it means your model is statistically significant. Now, another value that we can look into is F value. The F value, it should be greater than 4, which is quite bigger than that. We have 43.936, so it again indicates that our model is statistically significant. So these two things are quite good for us. And how do we report them? I'll show you how we write the results related to this kind of method here. Let me just scroll down to my results where I've written them. See, you can see over here, this is how I have written them. You can see it here. The R square value is this, which means that the model which includes this explains 32% of variation in the credibility. Now there's one more thing that should be written here, which is, I guess I have missed, that the model is statistically significant. And there are a lot of typos here. Okay, and how do we report it? We would write it in this way: F, within brackets, we write the degree of freedom. So I'll go and get my degree of freedom from there. I don't think I have the degree of freedom over here. So I'll just keep the space and then I'll put equals to. I remember the value of 43.96, so I'm putting that here, comma, and then we will put the value of significance, that is p value. Now we don't write the exact p value, we write it within the less than form, so we will say it is less than 0.001, and that is how we report it. It's a statistically significant. I'm just going back to my data to get the degrees of freedom. Now the degrees of freedom, how do we get them? Can you see here this DF column? It's 3 and 280. So this is what we need to write within the brackets here. So this is how we are going to write here: 3, 280. And this is how it will be reported. All right, so this is the statement that you need to make, or this is how you would report it. Now another thing that you need to report about this model is about the coefficients or the estimates. You have to individually look into each and every estimate and see whether they were significant or not. Now to establish whether a particular independent variable is significant or not, you have to look into, you can analyze it in 3 different ways. One, you can look into the significant sig values. These sig values should be lesser than 0.05. Now on this criteria, all the 3 independent variables are significant. Next, you can check the t values. Now t values, if you are conducting a 2-tailed test, it should be less than 1.96, sorry, more than 1.96. If you're conducting a 1-tailed t-test, it should be more than 1.64. Whichever value I may test for t, my t values are greater than that. All the t values are greater than 1.96 and even 1.64. Now, the third condition that we can check is our confidence interval. Your confidence interval should not have 0 in between them. The lower confidence interval value and the higher upper bound value, it should not include 0 in between them. Now, if you start from 0.14 and move on to 0.40, you won't get any 0 in between this range. And it is true for all the 3 variables that I have here. So all the 3 independent variables that I have are statistically significant. Great. Now, next we will move on to unstandardized beta. Now this 0.127, it tells us that if there is a 1 unit change in review quality, the credibility, the E-MOOM credibility would increase by 0.127 units. All right, it would be improved. It has a positive sign, and that's why we would say they have a positive relationship between them. So this is what we need to report. And finally, what we can do is that we can create a kind of a regression equation, and we can report that regression equation to show what the relationship is. I hope I have created one to show you that how it looks like. All right, I have another paper where I have created this regression equation, and I can show you over here. This is another report, but this is how we create the regression equation. Like, this is my dependent variable, and I have written the constant value here, then the unstandardized b's, the variables, and so on. This is the t value, the t statistic that I've mentioned here, and this is the standard error. This is a standard way of reporting your regression results that you get from the Spss. So that's all for this video here. That's all for regression analysis.